So today what I'm going to do is talk about a particular tool that I built, which has been very useful for people in DevOps and all of that. But it's going to be based on generative AI, and I'm going to walk you through how I built it using generative AI. Okay? And since this is not a topic that is not extremely famous or well known, it's popular but it's not well known, I'm going to walk you through some part of what generative AI is. Okay? So I'm going to do the talk based on what Gen AI is, give you an introduction, and then also walk you through how I built it. And the goal being that to let you know how to build tools like this yourself. Okay. I was wondering. So on Google Cloud, I do a whole bunch of stuff. Today there are about 10 certifications. There used to be 12, 13. And I've got all of them. And today I write the questions for these certifications for Google. In fact, if you go to the Google site, a bunch of those questions have been written by me. And we're working on, last year I did some projects for them on generative AI. This year we are doing something on, there's something called Google Cloud Air Gap. So that's something else that is going to come up new, where there's a cloud, but the cloud is under your desk. You can take Google Cloud and walk around with it using, like it's a suitcase, right? So if you want to run Google Cloud, but you do not want internet connection at all, like for military purposes or for if there's an earthquake somewhere, right? You won't have connectivity, but you still need to use Google Cloud. How do you do that? So we're working on some of that. On Google Cloud, I'm also an authorized trainer where I teach all Deloitte and all these other companies, Accenture, Infosys, Wipro, all the US companies, Australian companies, about how to use Google Cloud. On the GDE thing, Anubhav, like me, he spoke earlier today. There's a program called Google Developer Experts for people who are expert in a particular field, but also go and speak about it. So if you're interested to know about that or the certifications, do reach out. Okay. So what I built and when it started, last year, about September, Google gave us a whole bunch of credits and said, go build whatever you want. Here are some things, some Google Cloud credits to build generative AI applications on. Go build whatever you want, show us what you build. And I was like, okay, that's interesting. I've got free credits, let me go try something. But for me to build something in generative AI, I need to understand what is generative AI, right? So what I will walk you through now is a simple introduction to how generative AI works, enough for you to build applications like this yourself. Okay. So the first question is, of course, what can I build? And to start with understanding of Gen AI. So in generative AI, the way you start is you collect a large amount of data, right? And generative AI today has multimodal technologies, multimodal options where each mode is like video is a mode, image is a mode, audio is a mode, text is a mode. We are going to talk only about text just because it's easier to understand, and you can apply the same thing similarly to other modes. So if you're going to build a model for generative AI using text, what do you have to start with? You start with a large amount of text. Okay. Now, why do we want to build a model? A model is a representation of the real world. Okay. So for example, let us say, we want to predict at what time the sun is going to rise tomorrow. Why is that important? Because we need to plan when flights will take off, when people get to work, when we need to switch on solar systems, when we need to switch off the lights, all of these kind of things. Like street lights, you don't want it to be on during summer, right? Because in summer, by 6 o'clock, the sun is risen. But in winter, it will be maybe 7 o'clock, right? Where you need light. So you can plan a lot of a life based on when the sun rises. Okay. How do we do that? How do we build that prediction model? By collecting a large amount of data, right? You collect this data for decades, where say every day, today the sun rose at 5:58, today it rose at 5:59, today it rose at 6, and then you figure out what is that cycle. And once you have that model, you use that to predict what is going to happen. So in anything that we do, what we are trying to do is collect data about what there is, use that to build a system that we can use to predict, right? Now, why can't we just ask the system itself directly? Because it's too large. We can't go to the sun and figure out when it is going to rise tomorrow, right? So we need a simple way of calculating when that will happen. So in the same way, if we want to get questions, we're going to ask questions and get answers about real world situations, we collect data about real world situations. So this data can come from customer conversations, from financial analysts like PDFs that are sent out year on year, from textbooks, from storybooks. You collect all of that text, you run it into a system that will be able to create a model. Now, this is much easier than what we used to do earlier. So I used to work for a company called SITA, Societe International Telecommunication Aeronautic, which was a consortium of all airlines, airports and all of that. Anytime you step into an airport, anytime you step into a plane, when you order food, when you put luggage, we get that information, right? And we get that for like millions and billions of people across the year. And we have to collect all that information, process it, and then send out these invoices. Okay? So it was a big team that I was running out of Paris, where all these airports and airlines came together. To process this data takes a lot of effort, huge amount of effort. We had a huge pre-processing team. So when it comes to generative AI and building these models, we don't do that, right? No pre-processing. We just take this data, dump it into some kind of algorithm to come up with a representative model of that. Okay? So it's much easier to do. But since you're working with a large amount of data, it still takes a lot of time. Okay? Then what do? So we take all this data, we pump it into some kind of algorithm. Okay? That algorithm we're not going to discuss too much, but there are multiple such algorithms that you can use that. What happens inside this machine learning model building? So since we're talking about text, let me take a text example. If we want to build a prediction model for English, where we ask a question in English and we want it to give us a result in English, what do we need to start with? English words. How many English words are there? Hundreds of thousands of words. Okay. So in that model, first what will happen is, the model has no connections between the words. Let's assume that every weight over here is 0. Okay. So all connections between them are 0. In reality, you don't start with 0 because there's a problem with starting with 0. Okay. So what you'll do is you'll randomize these numbers, 0.1, 0.2 and whatever. But for sake of ease of understanding, let's assume everything is connected by a 0 weight. There's no connection between the words. And the first time the algorithm reads a sentence like this, in Paris, France's capital, the president said. The words France, capital and Paris, since it is appearing fairly close by, you increase the weights among them. Okay? So in the previous one, 0 weight. Now what you're doing, you're adding one weight saying 0.1, 0.1, 0.1. Okay? So you said, okay, there is some connection between the words Paris, France and capital. Then when the algorithm reads the next piece of information, say something like I landed at Charles de Gaulle Airport, Paris, France's capital, again you get a word, Paris, France and capital. So what do? You increase the weight. Okay, so again say, these seem to be connected in some way more than normal. And the next time it says, say some sports thing, saying that the finals will be played in Paris, France's capital. Again these words appear over and over again. Okay? So the connection between these three words is built into this model that is output. At the end of doing all of this, you get an output, which is a result of all those connections. So what is in there? What is in there is a large matrix of numbers. That's it. Okay? We started with a whole bunch of text here, but we end up with a whole bunch of numbers. That's all. It's very important to know that the original text is all gone. We have no access to the original text. Okay? So when you do like Google search, or let's say you go into a browser and you search for some word that is on the page, what does it do? It scans the page looking for that word, right? It's a text scanning. You're scanning it word by word. Here you're not doing that. Okay? At the end, we start with text, we end with numbers. And that has a lot of advantages, it has some disadvantages also. The advantage is that what would have been terabytes and terabytes and zettabytes of data is compressed into a few numbers now. What would have been petabytes, petabyte is 1,000 terabytes, a zettabyte is like 1,000,000 terabytes. That much data is now compressed, that much information is compressed into a few gigabytes. So instead of carrying the entire world's knowledge as text, which would be too much to carry in any kind of laptop or even cloud computers, you've compressed into a few GB that you can now put on your watch, you can now put on your laptop, you can put on your mobile and carry it anywhere. Right? So all that information is condensed into numbers that you can now ask questions to. Data is not there. The original data that you started with is not there. Instead, you have numbers to deal with. Okay. Having done this, yeah.
Like metrics you show, is it like a correlation metric?
The metrics that I showed, is it like a?
You showed the process where the text is converted into number metrics. Right?
Yeah.
Is it like a correlation metrics where the relation between words are arranged?
In some way, yes, right? So what will happen is, in this matrix now, it's a little more deep, but each one is a vector representing a word. Okay? And there is some kind of weight. It is not clear from what it is, but there will be some kind of weight saying the richness of that number, the size of that, text, right? It's represented in about 176 different entries in each column.
Each number in this is a word in the text in your column.
Each column is typically a word, yeah?
So each column is a
one
word in your column.
Yes, something like that, okay. But then again, these are all, I'm showing you one variation of that. There could be other variations of this. Okay. Cool. So now, if I ask a question, what is the capital of France? I'm going to ask you, how do you continue this conversation? Okay? You know the answer to this. And you know the answer to this immediately. You don't have to think about it, because our brain has two systems. There's a system one, which is where when you touch something hot, right? You don't think about, oh, this is very hot, I need to take my finger off, right? It happens immediately. And then there's a system two, which is when if I ask a question that you don't know the answer to, then you're going to have to think about it, right? If I ask you, for example, what is the capital of Australia? Can you tell me what's the capital of Australia? Capital of Australia? Sydney. Yeah? It's not Sydney. Okay. Somebody else did give another answer. But you see how when I ask you a question, you think it's Sydney, it's not, but you have to think about it now. Okay. Now what are you thinking? You're thinking of the different cities in Australia. How do you know the different cities in Australia? Okay, where have they played a cricket match? They've got a cricket ground in Perth, in Adelaide, in Melbourne, in Sydney. Is it one of these? Right? So the process of trying to find the right answer when you don't know it is to list what you don't know and then choose something that you feel most appropriate. Okay? So in this case, assume you don't know the answer to this automatically. What would you do? You will take all the words in the language that you know, right? And you list them. Then what you do? You attach a probability saying which one is the most probable. Alright? So in this case, we go back to the matrix. We run it through. We run these text through the matrix. It comes up with a certain probability saying these might be the maximum probability. Okay? Since it already has the word capital and France, and we've already drawn a relationship matrix somewhere, right? That says France, capital, and Paris are related. Maybe Paris is the most likely. I think that's switched off. What is that? So I will keep speaking anyway. You have a sense of what the words are, right? The words are France, capital, and now you're trying to relate it to what would be the next one. Yeah. So you say, okay, the next one is likely to be Paris because that is what the previous text that we studied, the sports news item, the news item, the travel item, all of them had France, capital, and Paris. So the next likely word is likely to be Paris. Okay? So you're running through, every time you want to predict what would be the next word, you're running it through the system. Okay? Running through the same system to come up with what would be the next word. Okay? So give me a moment here. Among the ones that were there, I choose something based on some probability and say I'm going to go for the first word I will give you. Okay? What is the capital of France? How would you compute this? Connect the matrix, get the probable words, pick one from that. And I'm giving you the option Paris. Now remember again, while the text is being studied, it is also imbibed the understanding of grammar. When you start with a noun, saying Paris is a noun now, yeah? What is the next possible word? What is the, if you have to continue the sentence, right? You're trying to answer a sentence, what is the next word? Is, yeah? So again, you run it through the same matrix. It says, okay, noun is there, now the next one has to be is, right? Typically you say, something is, that is, this is, yeah? So the next word will be is. Again, you run it through the matrix, okay? Now here's where I just pause for a moment and tell you what this is. This is called the query. This is a question that you've asked the model. When we start off, the query and the context is exactly the same. Okay? When I come up with the first word, the query is still the same, but the context is now, what is the capital of France? Paris. Okay? So the query was 6 words. The context after the first step, after the 0th step was 6 words. But after the first word is out, the context is now 7 words. What is the capital of France? Paris. So you put these words into the model and predict what is the next word. Now I have given you the next word also. There are 8 words. What is the next word after this? After this, next word is the. After this, capital. After this, of France. Okay? So this is all that the LLM is doing, where having studied how the language is usually laid out, how grammar is usually laid out, and how there are connections between these, like France, capital, and Paris, it has understood these based on just repetition. You keep repeating in different contexts, and the model, the algorithm is able to figure out that this is how it is connected. It's a fascinating way how the mathematics behind this works. I did another talk at another Google event where I start with random letters, and you put mathematics like, for example, English frequency. What is the letter that occurs the maximum times? You know which letter in English occurs the maximum time? The letter E, right? So you give it a high probability. Tell me a letter that occurs towards the end, something like Q, X, J. So mathematically, every time you choose a letter, you choose based on probability. E has higher probability, something has lower probability. Take random numbers, choose probability, you will start getting English. It's just madness how amazingly that works. It's not just based on English letters, but also based on things like word size. And there are some words that go together, right? Like is, the. If you have the letter Q, U will come after that, right? So if you put in some of those probabilities, you will start making, automatically you will start coming out as English. It's very surprising, and it's actually quite amazing. So in the same way, this is pure mathematics. You run English through it, get numbers, run mathematics over and over again, you start getting language. Not only you start getting language, you start getting wisdom. You start getting knowledge, like understanding, knowledge. You think that this model understands it, it doesn't. It's just mathematics. Okay? So it's quite amazing how this works, that you can run it through these mathematical systems and start making grammar. You can start having knowledge come out of it. You can think of it as a sophisticated autocomplete. So if you guys have used these old Nokia phones and all, when you do your SMS, you start typing it. If you type one word, it'll try to predict the next word, right? So it's just trying to predict what's the next word. But that uses a different kind of technologies called engrams and all, okay? Where given a couple of words, you're trying to predict the next word. So trigram will use 3 words to predict the 4th word, such and such. But that's not scalable. When you have hundreds of thousands of words, that kind of processing technology will not work in any reasonable latency. So if you start trying to predict what's the next word on a mobile phone, and you need all of the world's knowledge, it will be like an hour or 2 before the next word is predicted. Okay, so you can't use that. So this uses new technologies called transformers, which does this in parallel. While you are studying the 100th word, the 120th word is being calculated, 200th word is being calculated, all of that. Okay. So way more powerful technology. Now the interesting thing is, this process of figuring out what is the next word can apply to any language. I showed that for you specifically for English. What about for poetry? If I train the system by giving it a lot of poetry, and then I gave the context, roses are red, what will be how it completes it? Violets are blue, something, right? So any language you apply to, it will work. What about code? Same. If I write some code for open parenthesis where I equal to 0, what is the next character? semicolon. After that, there will be like a comparison operator, and then there will be an increment operator, and then it will finish that parenthesis and open a brace and all of that. Right? So any language you make a study over and over again, it is able to predict what is the next character, what is the next word. That's all. Okay? So it's very simple in that understanding. Obviously, the technology itself is way more deep, and there are podcasts on this that I listen to daily where they're making huge advances in the kind of research around making this fast, making this correct, and all of that. Okay? But at to the level that we need to understand how to build apps, that much is enough. Now my question is, okay, I've understood Gen AI. How do I build an application around this? Okay, what is there in my real life? What am I doing that I can use this for? So at that point, I was trying to buy a monitor. I had a laptop, I wanted an extra monitor, and I always come across these numbers like this. And I was like, what does this mean? I thought it didn't matter. Right? Then I understood that it does matter. And if you go to Amazon and Flipkart and all, they won't tell you what this means. Right? But if you're a technology person, you want to understand things like resolution, PPI, density, all of that, you need to understand this. Okay? This, if it starts with 6, it means that it was built in year 2016. If it has something like H in it, it means that it is high definition. S is standard definition. Q is QHD. U is ultra HD, so on and so forth. So this by itself is a language. There's a grammar to it, right? There's a meaning to how these are laid out, and therefore, what is the result? Okay. So I quickly built an app where if I give some code, if I give a product code, will it be able to give me the result? Okay. And this is not online right now, but it works. I would give something like what is a Sony XR65A90J, and it tell me exactly what that thing is. Here's the thing, I don't have a database of devices or product codes, nothing. I'm just asking the LLM, what does this mean? And it is understanding all of this based on data that it has already consumed. Yeah? And this works, you can try, you could try it out. Now I've taken it out. But then that worked. I sent it out, and then I said, okay, what do I build that I can use regularly? But one other thing, all these images are generated using Google's Gemini, right? So I just said, okay, I wanted one consistent theme for all the slides. So I said a chimpanzee in a pilot helmet and a pilot hat, and all of these are generated images. Yeah, all of them follow the same theme also, right? All of them. Anyway. So what else can I buy? What else can I build? Right? One thing I have a problem with is all the things that we do in DevOps, right? We've got so many tools to run, and I cannot remember for the life of me what those commands are and what the options are. And today what you're doing, you're invariably working on from one computer and you're controlling like hundreds of computers somewhere else, right? You're sitting here, but you've got a computer running in Iowa, another in Tokyo, another in Mumbai, and you're remoting into them and you're running commands. I was talking to a few people in Cisco and all of that. They were saying the same thing, right? They're running some 80,000 servers they're managing from one place, and they want to be able to remote into this and run commands over, right? And you want to be able to run it quickly. Another issue that he mentioned, and that also saw happen during CrowdStrike, when the CrowdStrike issue was there recently, right? When there is a problem, you need to be able to quickly run commands and figure out what is the issue. You don't have a UI and all that to figure out, because the UI is built on things that you know. And attack is based on things that you do not know. Right? So right now I'm building a course for Google on how we are doing security operations, SecOps, for certain kinds of systems, like the air-gapped ones that I told you about now. When you do not even have cloud, when it's just sitting on your desk, how do you run SecOps now? So when there's an attack, you don't have any predefined playbook. You have to go back to the core commands and figure out how to run it and figure out what is happening. Okay? If you had to figure out all that you need to run, what all are there? They're all the basic Unix commands, right? So there are hundreds of them, right? So for PG, for find, even if you just want to edit files, there are multiple commands. Then on top of that, if you are in Google Cloud, which is where I do most of my work, Google Cloud is a super command that has about 200, 300 sub-commands. Within each of that, there are again 10, 20 subcommands. Similarly for AWS, similarly for Azure. And today you're working in multi-cloud environment, so you need to be able to understand and run each of these. And then when you get into the whole CNCF situation, each has its own tool. There's Kubernetes, there's Docker, there's Istio, every single one of them has their own command. And I can't remember them, I don't care to remember them. I think there is this Sherlock Holmes story where Dr. Watson asked Sherlock Holmes, how do you remember all of this? And he says, you don't, and you shouldn't, because your brain and your memory capacity is like a room, and there's a capacity to it. And if you put more than what is capable, something else has to go off it, right? So, for example, you would have seen that, or maybe my daughter is here today. She can remember every damn thing. She's a 3-year-old. You ask her what she ate like a few days ago, how she ate it, she'll remember everything. If I asked you today, what did you have for lunch yesterday, you'll struggle to remember. Right? Because we have got so much other things to remember, we don't care to remember this. Yeah. So how do I outsource all this knowledge to a tool without me having to remember it? Okay, that's the goal. And that's when I built this tool called Dmcon. Before I get to that, if you're building apps in Dmcon, I told you already how generative AI works, a simplified version of it, enough to do all of these apps. Okay? In Google Cloud, if you're going to be building, it's very easy. Go to this thing called AI Studio, run your sample queries there, get the result, and then modify. There are 3 kinds of ways in which you can build these generative AI apps. Okay? There are 3 kinds of queries you can ask. One is the chat prompt. So when you use things like ChatGPT, this is what it does. When you ask a question, like what is something, it responds with, it is this. The next time you ask a question, it retains the previous question. Okay? Do you remember what this is called? It's called the context. Yeah. So in the earlier example that I gave, what is the capital of France? Paris. That is the whole context. When I say Paris is, that whole thing becomes the context again. Right? So every word, every output is the context for the next thing. Okay? So in the case of a chat kind of prompt, the previous conversations are remembered, which is great in certain situations because it improves the quality of your results. So for example, let's say you have a team, and there are a team of 10 people, you work together for 5 years. You immediately understand each other. Why? Because there's a shared context of all the things that you've done before. Now if a new joinee comes into the team and he says something, there is no context. Right? So the longer the context, the better the quality of the answers, because all of that information is there. But it also has a problem because as the context increases, the size of the computation increases. So the matrix that I showed you earlier, that is like, say, 1 billion columns or 1 trillion columns. You multiply 1 trillion columns by 1 trillion columns, the amount of time it takes is huge. Right? So you'll see that in ChatGPT and all earlier, the longer this conversation goes, the worse it gets, because it has to forget what is there on top. Right? There's only so much context you can hold in memory. The other one is where you give examples. If I have a few, given this, that's the answer, given this, that's the answer, then what would be the output? The other one is a free-form form where there's no memory. So this is how you run things like Google search. Every time you run Google search, it doesn't remember what you have run. Instead, what it will do is, every time you want to ask a new query, just ask it fresh. Okay? So I'm going here and I'm going to ask a command. Okay? So I'm going to go, let me just refresh this and say this, and let me put in this. Okay? So I'm just going to come here and say, what is the command to delete a form? And it gives me a whole bunch of results saying this is how you delete a form. Now I don't care about so much. I just want the command. Okay? So let me modify that a little bit by saying, don't give me all the explanation, just give me the command. Okay? And then I run it. And then it gives me exactly what I want. Okay? So here's the key thing to remember. I have got exactly what I want to run, but I haven't done any backend to this. There's zero backend. I don't have a list of Tutor commands. I don't have a list of any commands. I've just asked the LLM, how do I do this? And it does that thing that we studied earlier, where it says, what's the next word, what's the next word, what's the next word, to come up with exactly what I want. So how much time did it take to go from the prototype? Right? I mean, the idea that this, I want to do this, to building a POC, how much time did it take? A few seconds. Right? Now what I did was, I then went and wrapped it in a shell script. Okay? The same thing, I put it inside a little code. The code is also freely available. And I'm asking the same thing. And once I do that, it will give me the same answer, but there's a lot more extra JSON in there. So what I do instead is I run, which you can pull out specific fields from a large JSON. Okay? And using that, it has given me exactly what I want in a single file. Okay? So now anytime I want to run something, I just have to ask in plain English and it is able to generate this output for me. Okay, now the same thing, what I did was I did a much larger app. So here is what, I'm just asking Dmcon, which is the app that I built, and saying how do I find text files that contain the word hello. This is going off the internet right now, right? So it's going off my mobile phone, it might be a bit slow, but it's giving me all those answers. Okay. How can you do this? I can ask the same thing for using a different model, right? This is uses a default power model, this I'm using Gemini Pro, and it's giving me how to do the same thing. I can ask the same thing for Kubernetes, I can ask for Docker, I can use in multiple languages, French, Spanish, any of these languages, it just works. Okay. So here I'm asking how to delete a VM named instance1 in IO region 1. You can see that included those queries as part of the output. All of this is generated. Okay. There's no backend to this. It is just asking the LLM, getting the result, showing you the result. Okay. You can see some of the other things that are running. I've done the same thing for Azure, and then after this, I think previously I did for, this was for AWS. Same thing in Azure, how do you do it? Again, this, like I said, this is live right now, and it's going off my mobile hotspot, so it's a little slower than it usually is. What is this? Yeah. So for Kubernetes, Docker, anything that you use on for your DevOps or DevSecOps, you are able to get that result in a matter of seconds. The alternative would have been to go to the browser, search for it, find the pages, read through all of that, copy something, bring it back into the command line. Usually that will take you like, from starting on 10 minutes, it will take you like a couple of hours, right? By the time you modify the command and get this right. Instead in this, you are able to do that in a matter of seconds, right in the command line. You don't even have to shift out of the command line to get this to work. Okay. Cool. I think with that, my time is done. Okay. I will kind of stop over there. All of this code is free. I mean, at least the base code for this is already open source. So I'll share it with the organizers so that they can share it with you. I had originally written it in shell script. The first one that I showed you, I ran it in shell script. And shell script, is not that portable. If you want to run it on Windows, it becomes a problem. So I rewrote it in Go. And this is also available at gencommand.com. Okay. So with that, I'll wrap up. Is there any questions you have time?
So do you guys have any queries?